welcome back to part 4, possibly, of the Nixie Clock saga. Well, you might notice parts of the circuit. This is my breadboard, and we have from one of the videos the 180 volt PSU. I'm not sure if that was shown in a different video, but we have the real-time clock sat down here, and as you can see, parts of the powering are by copper strips that I can tack onto. That's the grounding one, and down here is a 12 volt line coming in. Camera's annoying, isn't it? Hang on, I'll just stop that. That should stop the annoying flickering. Here you'll see some comments. So I write down things like that's the RTC, it's a DS32 something. There's a bit of writing as to what the pins, what the wiring do, and over here there's bits of writing just to remind me of what it is. And down here you'll see the 7805 ? It's a 5 volt power supply. 12 volts comes in, it gets fed to the 180 volt switcher, it gets fed into the 5 volt linear regulator, and then it comes out of here, goes up onto this board where it is converted to 3.3, the ESP8266, and the 5 volts goes off to power WS2812Bs are currently under the Nixie tubes. Now there's only 6 of them. 6 on pulls enough current for the regulator to get hot enough that it needs to be sitting on a heatsink. You can see it's quite a heatsink, and it gets reasonably warm. Hence the added paperclip holding it all together. That's how it currently is, and we're going to move over from that to a switch mode supply. I'm going to use the MC34063 DC to DC switcher in buck mode. The last time I used it was for the 180 volt DC power supply, and obviously that was in boost. This is the circuit taken from the data sheet, so this is my starting point. So I'm going to knock up one of these on a small bit of board and see how it goes. I have changed the value of that resistor. They say it's a 0.33, and I've only got a 0.36, and they reckon that the output 5 volts, which is up to half an amp, which hopefully should be good enough. Because the problem here is you've got 12 volts coming in, 5 volts going out, so that's 7 volts drop across the regulator. And as you know, with linear regulators, the difference between V in and V out, because if this was running at say 7 volts in and 5 volts out, you got a drop of 2 volts. If it's pulling half an amp, you can calculate how much power it's dissipating. But of course, you go up to dropping 7 volts across it at the same current, and the power goes up a lot. So if you need to drop quite a lot from your input voltage to your supply, the voltage you need, then be careful with how much current you pull, because they will get hot. Well, I won't bore you with the build video, or the build part of it, so I've speeded it up and added a little bit of light music, and enjoy. Well, I've just speeded this up. It's a bit boring, you know. All I'm going to do is add 2 LEDs. I'm going to add a blue one to signify when the 5 volts is on, and the red one to show when the 12 volts is on. So nothing to write home about, and you know, just a little bit of KiCad action, so to speak. What I'm doing here is I'm going to look at the LEDs. I don't know what they are. Got 100, or I bought 1,000 I think from AliExpress a while back, and one's blue, one's red, and I have no idea what the forward voltages are. So I'm going to use this component tester that was built in the video a while back. I'll put a link to it at the top, and it will test the diode, tell me which way round it is, and it will tell me what the forward voltage is. And the forward voltage is important. Like I say, it's 2.93, because when it comes to calculating the resistor to limit the current through the LED, of course we need to know what the voltage drop across the resistor is and what the current through it that you desire will be. And so if it's on 12 volts, of course you take the 2.93 away from 12 volts, what's left is what's dropped across resistor. Divide that by the current you want flowing through the resistor, and you have that value. And as you can see, it's playing up. The probes don't like to make contact with the one on the side, and there is a fault in the software on this tester, that it just keeps recycling. It doesn't turn itself off. You have to turn it off with a switch. Turn it on by the switch, and then you have to press the blue button to make it work, but after that it will just keep cycling, because obviously there's a bug. And I'm just playing with it now to see if the red one's is just not working, or is it causing a problem. But shortly I think I'll add some wires onto the probe tips, and there you go, wires added, and there we go, flashing away. And see, that's only got 2 volts. That only have, well, that'll have 12 volts across it, so the red one's 12. So here we are, just adding the voltage to the diodes so that we can remember what they are. And so we'll have like 3 volts across that resistor and 10 volts across that one. So I've just calculated them out, and you can't actually see what I'm doing. Oh no, there it is. So 2K seems to be reasonable. I'm going for about 5 milliamps, so 2K, 10 volts across it. And the same with the blue one. I'm going for about 5 milliamps. So again, you know, 2 volts divided by 5 milliamps, probably about 400 ohms. Is it 400 ohms? Wait, oh no, yep, 390, closest value. And that's it, job done. Next bit, add the components to the board. And a little more light music. Just a parting shot, you know, linear regulator's gone, switch mode's in, lights are all on, LEDs are shining nicely behind the Nixies. I think on part 5 it might have to be talk of the software, so better start working more on that. So as per usual, hit subscribe, click on that bell, and I'll catch you on the next one.